Okay, so the next thing that we're doing today is still linked to finding the nth term of a sequence, except this time they're giving you patterns instead. So with these sorts of questions, there are going to be an extra step to do before we can actually work out the nth term. So example, there's a pattern of squares that are all built up from matchsticks. I have tried to draw it properly, but obviously they're a bit dodgy. We need to find the nth term and then see how many matchsticks we need for the 20th term. Now, the first thing you have to do with these sequences is actually work out, for this one, how many matchsticks are in each pattern. So if we start with the first one, so pattern 1 has 1, 2, 3, 4. So patterns, number 1 has 4 matchsticks. Okay, pattern 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then for the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so once we've done that, it's these numbers here that we've just worked out by counting the matchsticks that we find the nth term of. Okay, so to do that, we work out what we're having to add on each time to get to the next number. So to get from 4 to 16, we're having to add 12. And the same from getting to 16 to 28. So for part A, it's going to be 12n. Then we've got to find the number that would happen in the 0 term, or the one before the 4. So we're having to do the opposite of add 12, which is subtract 12. So 4 subtract 12 would give us -8, and that would be what would go on the end here. Okay, so that's part A done. So the first bit is always just counting how many matchsticks, or sometimes they use triangles, so how many triangles are in each shape. And once you've done that, you can then work out the nth term of those numbers. Okay, part B. We have done these sorts of questions before where we've tried to find a certain term in the sequence. So for this one, we're actually trying to find how many matchsticks we need for the 20th pattern or the 20th term. So all we do is we use our nth term, but we replace the n value with 20, okay, because we want the 20th term. So n's going to be 20. So we do 12 times 20. Make sure that when you've got a number next to a letter that it means multiply. Okay, so 12 times 20 is 240. 240 subtract 8 would be 232. So they're going to need 232 matchsticks to complete pattern number 20. Okay, and all of them are very similar, so we are going to do another one. This one is just linked to squares this time. Okay, but we're still having to do the same method each one. So we're told that the shapes below are made up with squares. So that means we're going to have to count the squares in each pattern. So pattern number 1, 2, 3. So pattern number 1 has 1 square. Pattern number 2 has 3 squares, and pattern number 3 has 5 squares. So these are the numbers that we need to find the nth term of, 1, 3 and 5. So again, we see what we need to add on to get to the next number. So we need to add 2 on to get to 3, and again we have to add 2 on to 3 to get to 5. So we know it's going to be 2n. Then we've got to work out what the 0 term would be, or the previous one before the 1. So at the moment we've been adding 2 to get to the next one, so we're going to do the opposite. So we're going to have to subtract 2. Okay, so 1 take away 2 is -1. So we write -1 on the end. Okay, and then again for part B, very similar to part B of the first EG that we did. We know what the nth term is because we've just worked it out. This time we want the 30th term, so that means that n is going to be 30. Okay, and we just substitute it into the nth term. So 2 multiplied by 30, and then we subtract 1 on the end. 2 multiplied by 30 is 60. 60 subtract 1 is 59. So it's going to have 59 squares. I'm not going to fit that in. Okay, so just remember step 1, work out the number of matchstick squares, whatever they say in the question. 2, you can then work out the nth term. And 3, you can work out then how many you need for each pattern.